So the VexIQ program is broken down into a couple of different modules, and the goal of the program is to get the students ready for competition coming up in September. So the VexIQ program uses VexIQ robots, so these are the kind of robots that you'd see. They're made out of plastic parts with motors, sensors, and a VexIQ brain, as well as a controller that can be used to control them teleoperated, so operated by a human operator. So the competition and the purpose of the competition is to get students interested in STEM and to get them competing on the international stage. So the VexIQ competition is broken into 3 different levels. There's the regional competition, provincial competition, and the international competition. And these 5 modules get the students ready for competition in September and hopefully get them ready to compete at the international stage against teams from around the world. So I'll start by outlining the 5 different modules. So we'll start off with Module 1. So the way that we bundle these together is we do Module 1 and Module 2, Module 3 all together. So Module 1 is made out of 5 classes that will be run during the summer, and the purpose of that is to teach them the basics of programming. So it's programming concepts that can be applied to other things. So just like how Gavin was talking about programming in programming competitions, it's a similar sort of idea. It's the same sort of frameworks that are used to program VexIQ robots. So Module 1 is all about programming. And then we get on to Module 2. So I'll just abbreviate this. So Module 2 takes what they've learned from programming and applies it to the sensors on the robot. So the robots have various different sensors that they use to move around. So they have encoders, they have different bump sensors like the one back here. They have light sensors, ultrasonic sensors, gyroscopic sensors, and Module 2 is all about using those programming concepts. So you don't have to have any programming knowledge going into this. We teach all the basics, and then it teaches you how to apply those concepts to the robot and the sensors to make it move and operate on its own autonomously. So that one's all about programming with sensors. So it looks at the programming that you've already been doing, and it adds sensors in there. And then we have Module 3, which is the last of the grouped modules that we do. So Module 3 is taking what you've learned in the programming and the sensors, and then it teaches the design and the build. Because you can program, and you can program these robots, and you can learn how the sensors work, but you have to be able to build them and design them for tasks on a field. So when you're doing that, we basically teach the different design concepts as well as the different mathematical things that you need to know in terms of building robots. So things to do with gear ratios, different design techniques. There's different ways that you can put linkages together in order to design motion for robots. So this is all about design. I like to call it mechatronics because it mixes the mechanical with the electronics. Moving on from that, we have modules 4 and 5. Module 4 directly has to do with the competition, and it's all about getting them ready to compete. So this is all about competition. In this one, we analyze the game and strategies in the game, as well as I give them a task which is similar to a robotics competition that they may see, and they basically spend a few of the classes working together collaboratively to try to find a solution to that problem and to build a robot that can compete. So it's all about getting them ready for that VexIQ competition and getting them ready to think strategically when it comes time to actually compete. And then finally, Module 5, which is the competition itself. So the way that VexIQ competitions work, it's a little different from most competitions. The CCC is a test that you write. So basically you spend a lot of time getting ready for the CCC or the CCO, and then you go in and you write that programming test. It takes about 3 hours usually to write it, and then that's the competition. With robotics, it's a little longer. So you get the competition in September, that's when it comes out, and then once you've got the competition, you're working together as a team for months and months and months until you bring your robot to compete on a field. So there's a lot of time there where you're designing and building a robot. and Module 5 is that time. So this is the actual competition. So it has multiple classes coached by me, and they build, design, program the robots for competition, and they go and compete in December, and from there they can move on to the next series of competition, going to provincials in Ontario, and then internationals, which are in Kentucky every year. Does anyone have any questions about the program, timelines?
What would be the ages which modules?
Right. So the ages are the same for all the modules. The VexIQ competition is grades it's grades 4 to 7, and 8 as well. 8. It depends when they were born for grade 8, but usually it's around 4 to 7, and 8 depends. Basically, all these modules can be anyone from any of those grade levels. If you're older than that or younger than that, you can still do the module. You just can't compete in Module 5. So you can do everything else, you just can't compete. So if you want to learn how to program, how to work with robots, that's absolutely great. And I highly suggest that you would come out and do that. But if you're younger than that or older than that, you can't compete at the end. Any other questions? Yeah?
Can you do yourself, or what background?
Oh, my background, yes. Okay, so I've been doing robotics for about 7 or 8 years, and I actually competed in VexIQ, and my team went on to win. We won second place in the world, so we placed second worldwide. This year, I've been working with different FRC teams. I coach a lot of FLL teams and a lot of VEX teams as well. So I have experience in basically all facets of robotics, and I've gone pretty far as well in terms of placing internationally. So, yeah. So there's a lot of other robotics competitions as well. VexIQ is really great for middle school, and it's really great because it's a lot newer as well, and it's really easy to get into at the beginning. Any other questions?
What's the underlying programming language?
The underlying programming language. So the underlying programming language is called Robot C. It's like a mix of C. So basically, it's C programming, and the way that I teach it is we use a graphical version of it, so it's a little easier for the students to understand, so that they can get into working with the robots a little quicker, so they don't have to understand the syntax as much. So it is C, and that's basically, yeah, it's just C, and we use a graphical version of it. Yeah. So if you want, you can look that up, Robot C, if you want to make a note of that on your sheet. Any other questions? Or no? All right. Thank you. Yeah.
So for the older student, can they join the Model 4 and 5 to get into the September competition?
Yes. So the way we're doing that is you still have time to compete in September. So what you would do is you do the modules 1 through 3 first. You have to do the modules 1 through 3 first, unless of course you have like some prior robotics experience, which I'll evaluate along with Henry. But modules 1 through 3, and you should be able to get those done in July, and then you can do module 4 and 5 going into September, because it is the competition time is long, right? So if you start late, you still have enough time to get ready for competition and be ready to go. So you would do modules 1 through 3 in the summer, and then you do module 4 in August and September, into September, module 5 until competition.
The competition starts September.
The competition, it technically, yes, it starts in September. However, you actually bring your robot and you compete with your robot on a field in December. So it's sort of like, it's kind of hard to explain. It's sort of like how sports teams, they would play sports throughout a season. It's the same idea. So the season starts in September, but you actually end up competing at the end of the season. So there's a lot of run-up time where they're working on the robot to get it ready to compete. So it's not like you're training and then you come in and you do the competition. It's you're doing the competition for weeks and weeks and months, and then you actually bring it and compete. So it's a little different. Yeah. And also, another thing to mention is that with robotics, it's not an individual thing. So kids are usually put in teams of usually 4 to 8, and they work together because it's the skills required. One kid can't necessarily possess the skills required to actually do it. So they're taught they need to learn how to work collaboratively with one another in order to design and program the robots. So usually they'll end up having specializations. So some kids will be more into the design, and they'll work on the design portion of the robot, and then another kid will be more interested in the programming, and they'll work on the programming portion of the robot. Are there any other questions specific to, yeah?
Yeah, so what are the equipment that you buy? You need a laptop computer and you have to buy the robotics?
Yeah, so we supply the robots, and it's suggested that you bring a laptop. The way that we run the class is we have one robot for a pair of students, and also one laptop for a pair of students. So if your kid doesn't have a laptop, or you don't have a laptop that you can give your kid, then we can usually supply one, or we can pair your kid with someone who has, with a student that actually has a laptop. But we suggest that you try to have a laptop. So we don't supply laptops.
And the laptop, like, it doesn't matter, is it Windows or?
Yes. Oh, yes. It has to be Windows computer. It has to run Windows, because Robot C only runs on Windows. So it is possible to run Windows applications on Mac, and it can be done, but recommended is Windows.
So Windows 10 or 8?
So this is what the robots look like that we use in the class. So it's a pretty basic thing. You've got an arm, claw, etc. And mounted on this one is a distance sensor. So it uses sonar to measure the distance to objects. So this program, I think it's this one, drives forward, and then it will stop when it reaches a wall, and then it will turn and try to find a spot that's open, and then drive towards that. So on this table, it's probably going to fall off, but I'll catch it. So it's, here we go. Okay. So I'll put my hand in front of it. So now it's looking for a spot to go to. So you can see that it's turning around. So this is like a program that you'd make, and this is a program from Module 2. So this is halfway through Module 2. If you look on your papers, it's under... Stop that. So on Module 2, it's the distance sensors. So this would be something from Class 3. Class 3 of Module 2. Are there any other questions? Or?
Do you need any experience or?
No experience at all. Just anyone who's interested, who has the want to do it, who has that sort of brain. No experience needed. We teach all the programming, all the design, everything. So I assume that the kids know nothing. Okay.
Thank you so much.